Hi there. I'm going to talk about a very interesting design pattern today, which is the strategy design pattern. Before going into the details of how this is implemented in the object-oriented world, let's take a look at this with a very simple example from real life. Let's assume you bought a cleaner robot to clean your home floor, and you have different types of floor at home. Carpet floors, hardwood floors, or even some unfinished basement floor, which is concrete. What you want the robot to do is use the vacuum cleaner to clean carpet floors, a soft mop to clean hardwood floors, and a broom to clean unfinished basement floors. The cleaner robot can have any of these cleaning tools, the vacuum cleaner, soft mop, or broom, attached to it before it starts cleaning a room. So the tools are interchangeable. Each of these tools represent a style or a way of cleaning floor, and each of these tools are an example of concrete strategy. Now there is a slot in the cleaner robot to which you are going to attach these tools, and you're going to attach one tool at a time depending on the type of floor you have in that room. That slot kind of represents a common interface that all these tools have to implement. In other words, these tools have to fit the slot accurately, and that's why that slot represents an abstract strategy. The cleaner robot holds a reference to one of these tools at a time, and therefore that cleaner robot is the context in our scenario. So in our example, we have seen the key players in the implementation of strategy design pattern, but our example is not related to object-oriented programming. We got the three tools that represent concrete strategies, the slot that represents abstract strategy, and the cleaner robot is the thing that uses the tools, and it is the context. Now it is your job in this example to attach the right tool. We are assuming that the cleaner robot doesn't have any kind of intelligence to pick the right tool for the job, so you are going to attach the right tool to the robot, and then you're going to just switch that on to clean a room. That makes you the client, and this is the fourth and the last key player in the implementation of strategy design pattern. You are the person who is going to set the right algorithm or tool on the cleaner robot. Now the cleaner robot, let's assume for now that doesn't know the details of how each tool works. So in a way, that cleaner robot is decoupled from each tool. And this is an oversimplified example, but let's assume that's true. Now in that case, as long as the tool fits the slot, the robot will be able to use the tool to do the cleaning job effectively. Now this implementation can be changed slightly to make this cleaner robot tool more intelligent. So rather than you having to select the right tool and attach to the cleaner robot before it cleans any room, maybe the robot itself, which is the context in our example, becomes smart enough to choose the right tool, or maybe this responsibility is delegated to somebody else or some other tool or machine. So that's a possibility, and we are going to take an example of this later in this presentation. So just to summarize, some basic ideas about strategy design pattern. So strategy basically represents an algorithm. Algorithms are interchangeable. Why are they interchangeable? Because they implement a common interface. This common interface is enforced because of the presence of an abstract strategy, which in the object-oriented world is an interface. Each algorithm, as we already discussed, is a concrete strategy. The context object holds a reference to a strategy. So in our example, our cleaning tool or the cleaning robot could hold reference to just one of the tools, but sometimes a context object can hold reference to multiple strategies. At runtime, a determination is made on which strategy should be picked for a particular job. So again, all these examples or these bullets represent the scenario that we just discussed, but they are applicable to object-oriented programming and the strategy design pattern in the context of object-oriented design. This is the class diagram of the scenario that we just discussed. So if all these objects and their interactions were implemented in an object-oriented system, this is how the class diagram would look like. Let's start with the right-hand top where we have iCleanFloor interface, which is the abstract strategy in our example. This abstract strategy is implemented by the three classes on the right-hand side bottom called vacuum cleaner, soft mop, and broom. On the left-hand top, we have the cleaning robot, which is our context. Please note that the cleaning robot or the context holds a reference to iCleanFloor, which is the abstract strategy. It also exposes a method called setStrategy, where the client class, which is shown left-hand bottom, invokes clean method on it, but first it calls setStrategy to set the strategy on the cleaning robot to one of the three classes, vacuum cleaner, soft mop, or broom, and then calls clean on it, and then the cleaning robot is able to execute the cleaning operation by using one of the three tools. We are not going to implement this example in our C# prototype. We are going to take something a little more practical. We are going to implement a search tool in an XML file. So the search tool allows the client program to perform searches on an XML file by using one of the two approaches. The first approach is the XML document approach, where the entire XML file is loaded into memory, or by reading the file line by line, which is the XML reader approach. I will provide a link to the source code in the description portion of this video, and also provide a link in the last few seconds of this video where you can see the source code. The two approaches mentioned above are implemented by two concrete strategies. The first approach is recommended for small and medium-sized files where the entire XML DOM can be loaded into memory, and then we can perform very fast searches on it since all that information is in the memory itself. The second approach is best suited for large files where an XML reader reads line by line, and when it finds a match, it returns the matching XML element. In our example, we are going to be doing customer ID search, and then we'll return customer name, which will be concatenation of last name and first name. Our example also includes the customer finder class, which is going to be the context. And we are going to take a look at this in more detail in just a couple of minutes. Now we are ready for our Visual Studio demo. So this is our Visual Studio demo. We have a solution called Strategy Pattern Solution, and it has got a console application called the Strategy Pattern Console application. Let's take a look at the source code. The first class that we're going to talk about is called the iSearch XML file strategy. This is the abstract strategy. And what does it do? It just exposes a method called getCustomerNameById, where you pass a customer ID and the full path of the file or the XML file from which data will be read. So this is the abstract strategy or the contract that will be implemented by the next two classes. The next class we are going to take a look at is called Memory Search XML File Strategy. All it does is it implements the same method, getCustomerNameByCustomerId, accepts customer ID as string and a file path. This is the file which stores XML data where we are going to do all the searches. The code here is not relevant. I have not used link to XML or any of the modern constructs. I've just used XML document here. And what I'm doing here is I'm loading the entire document into memory, and then I'm going to do an XPath search based on ID. And then if I find a match, I just combine the last name and first name and return the result as string. The next concrete strategy is sequential search XML file strategy. This uses XML reader. So what it's doing is it reads the XML file line by line, and if it finds the attribute of ID and if it finds a match, then it reads the last name and the first name, and then it combines the two and returns the result as last name space first name. Let's take a look at the context. This is the customer finder class, which is the strategy context for us. So this is the context class, and it holds a reference to the iSearch XML file strategy, the abstract strategy. It exposes a method called setStrategy, and when the right strategy is passed to it, it sets that to its local private variable. And then it basically, when the client calls getCustomerNameById and passes the customer ID and the file path, it knows what its appropriate strategy is, and then it invokes the strategy interface or the method called getCustomerNameByCustomerId and returns the string result. Please note that the context class has a dependency on iSearch XML file strategy, the abstract strategy, but it does not have any dependency on any of the concrete strategies. Let's take a look at the client program. Since this is a console application, the client program here is just the console main method. What we do is, in our example here, I'm just arbitrarily creating the sequential search XML file strategy, and then I'm creating the context. I'm setting the right strategy on the context, and then I am calling getCustomerByName and passing a hard-coded file. This could probably be something that I could put in the application configuration, but for the purpose of this demo, I'm just passing the XML file here. And finally, I just show a message to the user. So let's run this demo and see how it looks like. The application asks the user to pass a customer ID. So I'm going to pass 11111 and press enter, and I find the name Jones Stephen, or Stephen Jones to be more precise, and this is where the XML file comes into picture. I'll show you the XML file here. This is under solution items. So this is the XML file. So when I passed 11111, it found this node and gave me last name space first name, which is Jones space Stephen. Let's close this application and run it again. And this time let's pass an invalid number, -9, which is not in the file. And we get a result, no customer found. Now let's change the client to pass a different strategy. So here in our example, instead of passing the sequential, I'm going to pass memory search XML file strategy. And this time we are going to do a search on customer ID 99999. So let's go ahead, save and run this application. And let's pass 99999 and we get Smith space John, which is the expected result. So in this example, we noticed that the client class was able to set the appropriate strategy on the context and then call a context method, which in turn called the appropriate interface method on the strategy, and then we were able to get the results. So the idea here is, depending on the size of the file, the client has to make the determination of which strategy to choose. It sets that appropriate strategy on the context and then invokes the method, and everything works for us. This is the class diagram of the prototype that we just implemented. On the right hand top, we have the abstract strategy, which is iSearch XML file strategy, which is implemented by two concrete strategies on the right hand bottom: the sequential search XML file strategy that reads the XML file line by line, and memory search XML file strategy, which uses XML document to load the entire XML file into memory and then perform searches. On the left hand side, at the top, we have the customer finder, which is the context class that holds a reference to iSearch XML file strategy. And at the bottom, we have the client class that invokes the customer finder method, or the get customer name by ID method. And then first it sets the strategy, or the appropriate strategy on the customer finder, then invokes get customer name by ID, and that in turn invokes the appropriate method get customer name by customer ID on sequential search XML file strategy or memory search XML file strategy. You probably already noticed this, that there was a lot of scope of improvement in the code. And I'm not talking about the missing exceptions or hard-coded file path. I'm talking about how we could improve the design of our prototype. The first thing, the client is doing a lot of work. The client arbitrarily decides which strategy to use and then sets that strategy on the context and then invokes methods on the context, which invokes methods on the strategy. How about delegating the responsibility of selecting the right strategy type either to the context or to another object, maybe some kind of a factory class? Also, we need some kind of logic to select the right concrete strategy, and that could be based on some kind of configuration setting that we could change without changing code, and our right strategy selection would work. Let's see a couple of code samples here. In the first approach, one thing we could do is we could get the size of the file by using the FileInfo class in C#. And if the file size was more than this value, I believe it is 1 million bytes. So we're looking at approximately 1 gigabyte file size. And if the file length exceeded that, then we would select the sequential search XML file strategy. Otherwise, we would select the memory search XML file strategy. In the second approach, we could even put all this criteria in an XML file and then use system.reflection classes to dynamically create the right type of strategy and then cast that strategy to iSearch XML file strategy type. which is going to be the abstract strategy. And then all the client would do is pass this thing to the context object, and the context object would invoke strategy.getCustomerById method. Those are two of what I think are clear improvements in our design. I'm sure there are more, and I would love to hear from you. Finally, let's look at the strategy pattern definition from Wikipedia. Strategy pattern is a behavioral software design pattern that enables an algorithm's behavior to be selected at runtime. That is, the way an algorithm is implemented is selected at runtime, and we saw a couple of examples of that. So that brings us to the end of this video. Thanks for watching. I'll be posting links to my blog as well as a subscribe button. If you like this video, please subscribe to this channel, and my blog will have the entire source code of this presentation. Thanks again for joining.